high in exercise SYS-6, we have a very practical case. So we have 4 pumps which are totally identical in terms of their parameters, but these 4 pumps are located at different distances from the same power source, and the power source is 6 kV. So this is a very common task in industry, because the pumps can be, or any driving mechanism can be, at a different distance from the power source. So here you are to choose right topology, right voltage level for your electric machine and frequency converter, and you can play with that because you can use a transformer with different ratio. So you can have, for example, 3.3 kV solution, or you can have 400 volts and 690 volts in your system. And here you should be careful with what type of the transformer and frequency converter and filters between the frequency converter and the electric machine you have. So watch out for the length of the cable. So if cable is very long, then you should use a special filter. So if not familiar with the filters, please read this in the electronic textbook or in the internet. Another aspect is a cable selection. So you can play with number of runs for the cable, cross-section, and even material of the cable. So please try to write down parameters of all the components, like cable, frequency converter with filters and the transformer, everything, and compare the results and draw your conclusions on how length of the cable between the electric machine and the frequency converter will affect the cost of the system, the structure of the system, and everything in the system basically. So let's take a look at the software. So let's go down to the cable and see it is 30 meters in length, and the efficiency of the cable is quite high. It is over 99%, and the cost is around 1,000 euro. Losses are very low. But now if we change the length of the cable to, say, 400 meters and go down again, we see the difference is quite dramatic. So efficiency dropped by 4% and losses are much higher, and the price went up considerably. It is now comparable to the price of the frequency converter. So the copper and the insulation is expensive. But what if we change the material of the cable? So now it is much cheaper, this aluminum one, and efficiency is more or less the same, but this is because the cross-section went up. If we try to reduce the cross-section down to what it was for the copper, of course there's a risk that the cable will overheat, but price-wise it is okay. So at least we have something to optimize. If we know the cable is cooled quite well, we can go for it. Another aspect is a filter. So with so long cable, if you have read the textbook, you know you need to use a filter, DUDT, and this filter is going to cost. So the price of the frequency converter, you see, is higher than before. Just to compare again, 21,000 with filter and 90,000 without the filter. So quite considerable difference. From the previous exercises, you know how to choose the frequency converters and the transformers. So that's why I wanted to focus on the cable and the filter aspects of this exercise. So good luck and thank you for watching.